Hi everybody. I've had some questions this week about piecewise functions and what the quiz is going to look like. So I've gone ahead and made us some problems, very much like those that are going to be on the quiz, going over evaluating limits for piecewise functions and evaluating piecewise functions in general. So to start, let's take a look at problem number 1. And this asks us to evaluate the limit as x approaches 2 from the negative side. So it wants to know, if we imagine a number line right here, we're going to be approaching 2 from the left. So let's go ahead and look at our piecewise function up here. Which of these would be referring to the left-hand side of 2? That's an excellent question. So if we're approaching from the left, we would be looking at where x is less than 2. So, simple enough. It says right here, if x is less than 2, then g of x equals 2x squared. So, for number 1, it wants us to evaluate the limit as it approaches 2 from the left-hand side. So, let's go ahead and plug in 2 right here, since we're approaching from the left-hand side, and we're going to be using this function. So let's do that. 2 times 2 squared equals 2 times 4, which of course equals 8. So that would be the limit as x approaches 2 from the left-hand side. Simple enough, right? So now let's go ahead and take a look at the limit of x as it approaches 2. Not from the left-hand side specifically, not from the right-hand side specifically, just as it approaches 2. So, this is a bit trickier because it is absolutely possible for this limit to not exist at all. For it to exist, the limit as x approaches 2 from the left and the limit as x approaches 2 from the right must be the same. So, since we already know what the limit as x approaches 2 from the left is, let's just find x approaches, the limit as x approaches 2 from the right. And if those are the same, we'll know that this limit exists and it will be whatever 8, so assuming they would match. So let's take a look right here, limit as x approaches 2 from the right, g of x. So what would that equal? So let's take a look at the functions we have here. It wouldn't equal, g of x wouldn't equal this first function because obviously that's when it's approaching from the left. It wouldn't equal this either because this is just that specific point. It's not approaching from either side. It would, however, equal this because this is the right-hand side of 2. So where x is greater than 2, less than or equal to 3, not really relevant to what we're doing right now. So we'll go ahead and we'll plug 2 into this equation right here, and if our answer here equals 8, then we know that our limit is 8, and if it's not 8, we know it doesn't exist. So let's go ahead and plug that in and do that math. So 3 plus x cubed, our x with this will be 2, so 2 cubed, what does that equal? It equals 3 plus 8, which equals 11. Well, as we can see, this does not equal this at all. So that means our limit here does not exist. So it's important to keep in mind when it's asking for the limit as x approaches 2, it is not asking for g of 2. Because if it was, well, let's take a look at that right now. So right here for question number 3, it wants us to evaluate g of 2. So if we take a look right here, if g equals to, if x equals 2, which of these equations will we use? It's pretty simple. We'll use this one right here because it says x equals 2. So g of 2 will simply equal 5. Very simple. You love when that happens. But you notice, this and this are not the same, and that's a very easy mistake to make when you see the limit as x approaches a number, to just assume that that is where g of that number. You assume those are the same thing, but they're not. So just watch out, make sure you don't get mixed up. Alright, now for number 4, let's take a look at this. Is g of x continuous from the right at x equals 3? Well, I don't know. Let's take a look. So, to know if something's continuous, two things must be true. The limit, for something to be continuous from the right. So the limit, as we approach that point from the right, must be defined, and it must equal the function of that number. So let's take a look. For number 4, what we want is we need the limit as x approaches 3 from the right, so that'll be a little plus right here, of g of x. What we need is for this to equal g of 3. Okay, so let's start by finding this limit. Let me rewrite that right here. Limit as x approaches 3 from the right, g of x. Now what does this equal? If we're approaching 3 from the right, we're approaching from the side where x is bigger than 3. So which of these equations will we be using? We'll be using this last one right here, where x is greater than 3. So let's go ahead and do that. We'll plug 3 into this equation. So 3 squared plus 1 simply equals 9 plus 1, which is 10. So there we go. Now, we know this value, but we know this value must equal g of 3 for this to be true, for this to be continuous from the right. So now let's find g of 3. G of 3 equals, so will we be able to use this equation? We will not, because if g equals 3, it would actually be this equation, because this is only if x is greater than 3, not if x is greater than or equal to. This equation, on the other hand, does include 3. So right off the bat, we know there's a good chance these won't equal each other, but it's always good to follow through and check. So let's go ahead and do that. So g of 3 equals 3 plus 3 cubed. So that equals 3 plus, not super great with arithmetic like this, so let me break out my calculator. 3 cubed, 27. Wow. I guess I imagined that'd be harder than it was. So 3 plus 27, and that equals 30. Now, while we found both parts of this problem, we have found out that they do not equal to each other. So we know that it is not continuous from the right at x equals 3. So that's going to be a no. All right, but let's take a look at this. Is g of x continuous from the left at x equals 3? Well, maybe. So let's take a look up here. So we're trying to see from the left. So the first thing we want to do is we want to find the limit as x approaches 3 from the left, g of x. So what does that equal? The limit as that approaches from the left. So we're going to plug that into this equation, because if we're coming at it from the left, it's going to be less than 3. So let's go ahead, we'll plug 3 into this equation. 3 plus 3 cubed. And if you remember, we already found this answer right here, and that equals 30. So nice and easy, we found out what that equals. And now we also need to find g of 3. Now if these equal each other, we know this will be continuous from the left. So g of 3, what will we plug that into? We will also plug it into this equation, because this equation does include 3. We had discussed that earlier. So if we go ahead and do that, which you can probably already see where this is going, we will find that we get the same answer, meaning that it is in fact continuous from the left. I hope this helped. If you have any more questions, please let me know, and I look forward to hearing back from you guys soon.